What makes us so good at recognizing patterns? And why does the spiral of a shell look so similar to the shape of a galaxy and the spiral of a hurricane? Is it that our minds are seeing patterns that aren't really there and we're imagining them in a random world? Or are we actually seeing signs of a deeper mathematical order in the universe? To answer this, we have to go back to the very beginning. Most scientists believe that the universe began with the Big Bang, about 13.8 billion years ago. But when we ask what caused the Big Bang, science doesn't really have an answer. Physicist Brian Greene argues that this is actually a meaningless question. He says that in most cases, we know how to talk about the moment before something happens, but when it comes to the Big Bang, the sentence doesn't actually mean anything, because that's the moment where time itself began. Here's an analogy. Imagine you're walking north, and if you use a compass, it's fairly easy to go in that direction. But there's one place in the world where you can't do that: the North Pole. If you're already standing exactly at the North Pole, then asking, how can I go more north, doesn't make any sense, because you're already as far north as you can go. You can't go any further north than the North Pole itself. And in much the same way, it doesn't make sense to ask what happened before the Big Bang, because the Big Bang is the moment that time began. You can't go further back in time than the beginning of time itself. Whether or not you're happy with this answer, there's another way to think about the beginning of the universe, in terms of numerology. Imagine a timeline where we use the number 1 to mark the beginning, the start of something new. And on the same timeline, we can think of the number 0 as the moment before the beginning. We can use this to figure out what the next moment will be, like this: 0 plus 1 equals 1. If we want to see what happens after that, we continue the sequence and we add the new number to the one before it, like this: 1 plus 1 equals 2. And to find out what happens after that, we add each new number to the one before it, like this: 1 plus 2 equals 3, and so on. And if we keep doing this, we get a string of numbers that goes on forever. And it might look like a random list of numbers, but it's not random at all. It's called the Fibonacci sequence, and it's named after the Italian mathematician Leonardo of Pisa, who later became known as Fibonacci. He introduced this sequence in Europe in the year 1202, but it's actually even older than that, and it's believed to be first discovered in India at least as early as 200 BC. But the baffling thing is, this sequence shows up everywhere in nature. We see it so unexpectedly and so often that there's a whole scientific journal dedicated to studying it. It's called the Fibonacci Quarterly. One of the clearest examples of this is that we find the Fibonacci sequence in almost every kind of plant and seed. If you cut a cross-section of a banana, you'll find that it has 3 sections. An apple has 5. Flowers also follow the same pattern and will have 3 petals, or 5, or 8, or 13, or 21, and so on and so forth, all Fibonacci numbers. But there's another fascinating implication here. If you divide almost any Fibonacci number by the one before it in the sequence, you get a number that looks like this, and it goes on and on. It's an infinite number. Again, this looks like a random number, but it's not. The ancient Greeks called this number phi, but maybe you've heard about it by a different name, the golden ratio. And much like the Fibonacci sequence, the golden ratio also shows up all around us in nature. Here's how we can see this. Make a rectangle with the dimensions of the golden ratio. And if you keep making a series of bigger rectangles using Fibonacci numbers, you can draw an arc from one corner to another, making a spiral. And this shape actually reflects many of the spirals we see in nature, including storms, tornadoes, and hurricanes, all of which spin according to this pattern. And you can find this very same spiral in shells, galaxies, and even the human ear. In fact, there are countless examples of the golden ratio all over your body. Go ahead and hold out your arm and look at the section between your shoulder to your elbow and your elbow to the tips of your fingers. you'll find that these dimensions follow the golden ratio. And again, the section from your elbow to your wrist and your wrist to the tips of your fingers. This also follows the golden ratio. And even further than that, from your wrist to your knuckles and your knuckles to the tips of your fingers, again, follows the same ratio. And as Leonardo da Vinci found in his famous work, The Vitruvian Man, we find the golden ratio in the dimensions of the entire human body. But maybe you're still skeptical. You might say, well, we can find patterns in some areas of nature, but what about chaotic systems? In 1979, when mathematician Benoit Mandelbrot came up with this simple equation, he had little idea that it would completely revolutionize science and lead to huge contributions to chaos theory and fractal geometry. Here's how the formula works. You take a number, square it, you add it to the original number, and then you continually feed it back into the equation, processing it over and over again. And using this formula, you can generate patterns that repeat infinitely. And if you go deeper into the image, you'll find smaller copies of the original shape. These patterns are called fractals. Anytime you see a figure where a small piece of it looks like the whole, that's a fractal. The fascinating thing is we see fractals everywhere, all around us, in the shapes of lightning bolts, in the jagged coastlines of the ocean, and even in the shape of broccoli. In fact, you can even find fractals inside your body. Your lungs are fractals, and so is your circulatory system. In a very real sense, we are all living and breathing fractals. What this suggests is that there's a powerful connection between numbers and our physical world. And the deeper we go, the more it looks like there's an inherent mathematical order to the universe, which raises a profound question. Is math something we invented, or is it something we discovered? Many skeptics argue that numbers are just figments of our imagination. But even Albert Einstein wondered if math is just a creation of our minds, then why are numbers so good at explaining the universe as we see it? Why do numbers correspond so well with the actual patterns we find in nature? And if math is something we made up, then why is it so universal and consistent? Many scientists describe this sense that numbers somehow predict what our universe will be like, even before we investigate it. And the fact that numbers are so good at this is one of the deepest mysteries of the universe. Eugene Wigner calls it the unreasonable effectiveness of mathematics. And the fact that numbers describe the universe so well is a gift that we neither understand nor deserve. All of this points to the idea that there's a hidden mathematical order that underlies all of reality. And the connection between numbers and the physical universe runs deeper than many of us would like to admit. We might think of this as a recent discovery, but it's actually a very old idea. We find it with Pythagoras, an ancient Greek philosopher and mathematician who lived between 570 and 495 BC. Pythagoras believed that numbers were the most fundamental pieces of reality, and it's only when we understand this more basic level of numbers that we can begin to really make sense of the world around us. This led Pythagoras to the idea that the universe itself and everything in it is constantly vibrating. He believed that the universe runs with mathematical harmony and precision, and in the same way that each string in a harp vibrates at its own frequency, every planet, star, and galaxy also has a unique vibration. He called this idea musica universalis, or the music of the spheres. And it was precisely this insight that led Pythagoras to say that everything is number. Most scholars now recognize Pythagoras as the father of modern numerology, as it's practiced today. He spoke these words hundreds of years before the birth of Christ, and yet even then he recognized that the universe has a kind of mathematical framework, a logical order that seems to reflect a deeper and hidden structure to reality. As the next 2,000 years have shown, he was right. And today, with all our advances in science and technology, we seem to be uncovering the same truths that Pythagoras discovered all those centuries ago. According to numerology, the power of numbers goes much further than the spirals we find in nature or the fractal patterns all around us. Using the unique numbers in your life, you can unlock insights into your personality, your relationships, and your approach to life itself.